Manjan and welcome to the 6th video tutorial of the Verilog course series. In this video, you will be getting to know how the ripple adder works and how to design a Verilog code for ripple adder. For a better understanding, I split the video into three parts, that is pre-coding part, coding part and the post-coding part. Now let's move on to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram of the ripple adder, in which you will find 4 full adders, that is full adder A, B, C and D. For each of the full adder, you will be getting 3 inputs and 2 outputs. And for the first 3 full adders, you will be driving one of the output to the output as an input for the successive full adders, and you will be getting 5 outputs for the ripple adder, that is S0, S1, S2, S3 and C3. And coming to the functionality, you will be seeing that you will be giving 4-bit number, 2 4-bit numbers, and getting the output as the sum of those 4 4-bit numbers. That you will be giving those numbers as in the form of single bits. That is, if let's say I will be giving 2 4-bits numbers. First 4-bit number is 4-bit 1111. That is, and the another 4-bit number is 4-bit 0000, and I will be giving here 1 1 1 1 and B0 as 0 0 0. That means you are splitting the 4-bit into single bits and giving each bit to the full adder. Now let's move on to the coding part. And here in the coding part, I instantiated the 4 full adders in the name of full adder 0 1 2 3, and here is the port list I given A0, A1, A2, A3 and so on up to CN, CIN and S0, S3 and Cout. And if you keenly observe, I didn't mention the C1, C2, C3, that is here, not C0, C1, C2. I didn't mention it. I mentioned them in the wire because they are just driving the values but not storing those values. Okay, so I given CIN as 0 as the ripple adder will take the CIN as 0. So here I instantiated it. If you don't remember this, how to design this full adder, just do check my video on my playlist in Start Scratch YouTube channel. Now let's move to the post coding part. Here is it, and here is the full adder code. And here is the ripple adder code. Here in the ripple adder, I just instantiated the full adders here, and same as I mentioned in the presentation. For the time, to save the time, I already pre-simulated it, and here are the results for it. As I taken the example of 111 and 000 in the presentation, I given the same inputs here also. I get the sum as 111. That means 1 plus 0 is 1, so that I got 1, and carry is 0 itself. So to give another example, I will be taking like here I will change it as 0. Here I change A3 as 0, so I will change here B3 as 1, so that the output will be again same. Here the output should be same. Here I will simulate it for 10 nanoseconds. See, if you closely observe, here the output is 111, 4 ones and 4 zeros. Now if you come here, it is again 4 ones and 4 zeros. Now if you really want to see the schematic, I will show the schematic. And here is the schematic, which is just similar to my one in presentation. I am giving C0 to full adder B, C1 to full adder C, C2 full adder D. Now I will be showing this one in here. this is the full adder 0, which means this is the first full adder A. I will be getting seen as ground because it is the value equal to 0, and here the Cout is driven to Cin, that is full adder 1, and this Cout will be driven to full adder 2, and this full adder 2 is again Cout is driven to Cin as full adder 3, and here are my outputs S0, S1, S2, S3 and Cout, and here are my inputs. If you like the video, just share it to your friends and subscribe to Start Scratch.